is digital mobile radio, and our speaker's been an amateur radio operator for 23 years and a telecommunications technician for 26 years. He's a microwave band enthusiast and a soda mountain operator. He's also a maintainer of several of Sydney's digital and analogue repeaters. Constructed Australia's first DMR trunked radio network with over 7,000 subscribers, and set up Sydney's first amateur radio DMR IP linked repeater in the hope that the mode will catch on. Ladies and gentlemen, let's give a warm welcome to our second speaker, VK2 CU, Justin Wavery!
Thank you. Okay, well, thanks for the introduction. This is all about DMR, digital mobile radio. A fairly new standard. It's new to the game, not as old as P25 of course. But it has several interesting features, and hopefully people might get interested in this particular system. Anyway, start off. The company that looks after my computer did some things to it last week. That might be why it doesn't work now. Oh, okay. What's that doing?
It's working.
What is DMR? That's it. What is DMR? Standard. It was a standard developed by, as most things, Motorola. And it's also known as the marketing name is also known as Motor Turbo. So if you hear someone say, "Oh, I've got a Motor Turbo radio," it's the same thing. And anyway, I'll just move on. Right. So as you say, well, you know, what benefits of having of DMR? DMR, unlike P25, P25 is a standard that's mostly used by emergency services and governments with deep pockets. For example, a radio like this one, which has got GPS tracking and everything else, it's got applications, can do text messaging, is about $1,600, whereas an equivalent P25 radio brand new is about $3,000. And part of the reason for that is that all P25 equipment has to have a license purchase for it, which is about $500, and that goes back to the big M. I think it also goes to some standards institute somewhere as well. But anyway, so DMR was set up as a way of replacing FM for commercial applications, for commercial users, where your money is very, very important. And one of the things is for a radio company is you've got to go to, you can't just go to a customer and say, hey, I've got this new digital radio system. And so what does it do over analog? Why should I bother leaving analog? It does what I want. What can DMR do? One of the things it can do, one of the key things it can do is it can do two simultaneous conversations, or basically, essentially, it's like having two repeaters over one system. So the actual VK2RCG in town, which is one of these, it actually has two time slots. It has an international one and it has a local one. So you can have a local conversation going between amateurs in Sydney, and then someone else can pop up and talk to somebody in New York. That's the features of it, all over the one box. So it's essentially, it also, I think, as explained here as well, it will work with FM. So you can set these up into dual mode. So just like P25, like Carlingford, for example, whatever it sees in, it sends out. So it sees FM, it sends it out again. Likewise, it sees DMR, it'll send DMR out again. They will not, if you have a DMR portable and someone talks on the repeater on FM, it will not do a translation. So it's in like for like. That's what they do. One of the good things about these radios is of course with DMR is that they've got really, really long battery life. So a heavy commercial user can expect a complete shift of say 12 hours without needing to charge their battery. These radios in particular as well, the battery can actually tell over the air back to a central console in a dispatcher environment that the user's battery is going flat. It also can tell when the battery is exhausted and no longer in use. Instead of having people picking up batteries, running out to go do a job and then finding the battery dies within an hour, that doesn't happen. So it does a lot of, essentially the whole platform they completely started with a clean sheet and tried to do all the features that modern technology now has with the internet, linking and whatnot. Each of these radios even has its own IP address in it, so they're kind of they've been developed with IP and internet linking in mind. They can also do data. You can have telemetry. So let's say you're a big utility company and you want to have all your staff with radios. It can also do telemetry back to base as well. So you don't have to have two networks. You don't have to have a telemetry and a voice network. You can do it all over the one system. Weak signal performance. This works better than FM, especially in underground and inside buildings. It works very, very well. Penetration is quite good. Another key good thing about this is it's multi-vendor support. I've got some people coming up with other radios. As you can see, there's a tape radio, and this talks to these, no problems at all. So a whole lot of vendors have got behind this standard. So the only vendors who seem to be a bit slow on the take up are the usual Japanese ones. So they seem to have gone down their own path, although they are members of the association of the DMR. Anyway, audio performance, it's quite good. It's not as good as DMR, P25 stage 1. That's what was just demonstrated here. So that uses more bandwidth, but consequently gives better audio performance. The next standard, P25, does exactly the same as this. It actually has 2 slots in the one channel. It sounds a bit tinny. It doesn't sound as nice as the old stuff. And this sounds a bit tinny too, but when you think about it, you are trying to compress a hell of a lot out of a 12.5K channel. So essentially these are 6.25K radios. That's all the bandwidth they require. Advanced control features, like I said before, you can control the batteries, you can even turn the radios off, and we also do programming over the air. So if we've got a customer out of Bathurst, what we do, instead of having to drive out there to program and then get everybody to come back with a fleet of radios, we can do firmware updates and do channel changes or talk route changes straight to the keyboard. It sends it out via RF. They also provide their RSSI and various other features as well. Gone are the days of driving around in a car with a laptop and a GPS and doing coverage studies of a certain system. You basically you let the users do that, and it gives you all the coverage studies that you need. So, you want that? Now, who is playing the DMR game? Well, these are all the manufacturers that are doing it. There are quite a few Chinese manufacturers who are getting on the DMR bandwagon, and they are responsible for getting radios now as cheap as $250 for a port, brand new, not second hand. And there's now mobiles that have been released which are $280. So DMR's not expensive, and of course there's second hand radios such as these. You know, these are all current models, but there are second hand ones available now because DMR has been out now for some time. So if you do go down the DMR path, you're guaranteed plenty of support. Right. Okay. Hang on, I think I've gone past one now. Sorry. No, I haven't. Right. Types of DMR. Now, when they brought out the standard, they started off with Tier 1. You'll often hear people saying, oh, we got Tier 3 compliant and all that sort of thing. Well, this is essentially quickly what it means. Tier 1 is unlicensed, like the European versions of CV. And lipids, those horrible things that cause us so much grief. Things like cordless phones and that as well can actually use the DMR standard if they wanted to on I think it's on 449 megahertz, and they're limited in channels. That's just a European, because this was originally ratified by the Europeans, although the Americans have since adopted it. So it is a global standard. There's not European standard and then there's American standard. It's one standard. Tier 2, this is what we're using today. This is what the amateur radio DMR global network is using. They're using Tier 2. The Orion network, which is that large network which was mentioned before that I've built, that also is a Tier 2 network. Tier 3 is for trunking, and essentially it's to replace the old MPT type trunk radio networks. However, it's not a ratified standard yet. So some people, such as these people, are claiming that their radios are Tier 3 compliant. But how can they be compliant when the standard hasn't even been set? And essentially the Tier 3 goes further into the standard as far as setting things like some of the really good features that these radios have got for text messaging and other functions. but every manufacturer at the moment seems to be going and often doing their own thing. But if a radio is tier 2, instead of tier 3, it will be tier 2 compliant as well. You don't have to use all those features. In most cases, they're manufacturer specific. Sorry about this. Deal. So anyway, so what have we got today with amateur radio? As mentioned in the previous talk, phase 1, which is uses C4 FM modulation. To give you a rough idea of what it is, I don't know if you can see this, but if you imagine the particular channel as a 360-degree circle, it actually has subcarriers in 4 quadratures. So that means that it can do a lot more data for a given channel space. The quadrature amplitude modulation is very, very similar to that. The thing that as I think I mentioned before, the problem with P25, not the problem, but the issue with P25 and why we haven't seen any cheap P25 radios and amateur radio companies making P25 is because of that licensing issue. Although not only do they have to pay to be P25 certified, they also have to pay for this. Those vocoders aren't free. So with a P25 radio, essentially the manufacturer pays one-off license fee for that vocoder to use for its products. Of course, that cost is built into every radio they manufacture, and of course with the P25 license fee as well. So it adds to the cost. D-Star uses a slightly different modulation technique, but it still uses an improved version, advanced I can't remember, sorry, I wrote notes about that. It uses improved multi-band excitation is what it's called. That's what it does. Essentially, it chops up your audio and compresses it. And how it does that is the nature of the human voice is you can guess how, when you're reassembling that data, you can guess to put it all back to something you can hear. So it's a technique also used in other digital products like CD players and whatnot. So that's essentially what all these digital radios need to have. To take analog, convert it to digital, send it over the air, and then convert it back again. Okay, as I mentioned a bit before about phase 2, they are essentially doing 2-slot TDMA, which is exactly the same as this. This is 2-slot TDMA. TDMA is also used, I believe, in the GSM standard, except it's 30 slots. So each GSM channel has 30 slots. We only have 2. That's all we need for the moment. So that's how it's doing it. P25 is doing the same thing. They are moving to a 2-slot TDMA system to improve efficiency. Anyway, Fusion, it's C4FM, the same as DMR. I don't know too much about Fusion. I don't think anyone really does, but it is a C4FM standard, the same as DMR. Now, the issue here is, people say, oh look, why go down DMR? It's a commercial standard. It's not true amateur radio. It's not open. It is an open standard, but don't forget, D-Star, even though everyone says it's an open standard, the manufacturer would still need to purchase that vocoder. So ICOM has done that. Why other manufacturers haven't followed it, I don't know. Anyway, so there's no such thing as a true digital amateur radio standard unless we come up with our own one that doesn't do our own vocoders. And I imagine that's pretty hard stuff.
There is one.
Yeah,
There's one?
Guy in South Australia.
Codec 2.
Okay.
Yes, but he also pays a lot to the processing who does the processing.
No such thing as a free.
No such thing as a free licensing.
Okay, so fees and charges. So as I said, that's just what I was mentioning before about these, people wonder why some of this stuff costs a lot, and that's what you're paying for the Boltons who came up with the actual thing that makes it work. Okay, more with less. So I was mentioning before, 2-slot TDMA. Essentially, you instead of having to have 2 repeaters and then expensive combining equipment, which can sometimes cost as much as the base station, to try and provide a service, you're actually just sharing that infrastructure. So it makes things a lot more simpler. Like I said before, with amateur radio one, we have an international and a local. Right along. Okay, efficient use of radio spectrum. So in our case with amateur repeater applications, they're all 25k channels. Commercially, everything's moved to 12.5. And obviously for example, if the old days of using one 25k channel, nowadays we basically have 4 conversations out of the one channel, so 4 separate systems. So it also means for someone who's buying this equipment, they only need to buy one of these instead of having to buy 2. It saves them money. And that helps us as a radio company that we're trying to sell this, and eventually it helps amateurs because eventually that stuff gets replaced, and who ends up with it? We do. Okay, so the DMR is more spectrally efficient than other digital modes. This is a simple thing. It's a bit sort of simplistic and sort of a bit of a false argument, really. But to have two channels, two 12.5 channels, you still need that guard band in the middle. But because it's all coming out of the one box and the one transmitter, you don't need the guard band. So you don't have interference between DMR is actually its emission designator is 7K6. It's actually quite efficient. You understand emission designators and how much bandwidth something takes up. Well, it's pretty efficient. Okay, so once just mentioned before about the improved voice performance, it actually will work down into the noise floor where FM won't. So you can still hang in there. It gets a bit blocky or gets a bit R2D2y, but it can work. It does work better down in weak signal environments. Okay. Any questions before I go on? Either I'm lost yous or I'm doing a good job.
You're doing a good job.
Okay. Everyone can hear me? I don't need the microphone.
No. Hands are right at the back.
Right at the back. Okay, as far as amateurs concerned, the DMR Mark network. This is what is us here. So this is the system that's been developed by the Motorola Amateur Radio Club. These are the engineers in Illinois who developed this stuff. So they're pretty smart amateurs, and they've built this network which is growing like topsy. It now has 400 repeaters around the world. Essentially, it works off the talk groups that these radios use. So you can put any DMR radio on this network. It doesn't matter, even the cheap $250 radios. I personally think it's kind of in a good way to spend a bit more and get something like this because people have written the code plugs. The code plug is the information from your computer you need to put into the radio. And if you've got hundreds and thousands of call signs in your group list, it's very easy just to get that code plug, clone it into your radio and you're away, rather than have to sit down and type it all out. That's if you want the IDs. For example, when I key up this radio, somebody else's radio will come up with my name and my call sign on the display, so they know exactly who I am. And the talk groups also, there are lots of talk groups out there. For example, if you speak German, you can get onto the German talk group, the German language talk group, through the Sydney repeater here, and you can talk to people in Germany or wherever in the world they may be. The only trick there is though is you can't just turn onto that talk group and sit there and wait for something to happen. You've got to key the radio up to tell a thing called, I'll get there in a minute, there's a thing called a bridge. These are the things that hold this network together, and it needs to know that you're there, so it can send the traffic to the repeater up in GPT, and then you'll hear it. Network architecture. Okay, so this is I don't know if you can see it that well, but this is essentially what I was just mentioning before. These are bridges. So there's one in Australia, and then the repeater at Governor Phillip Tower goes into that one. That one then goes over to the central bridge in the USA. So you need to let these bridges talk to each other, but you need to let that bridge know that you're there. For some talk groups. Other talk groups, for example, the talk group number 1 is global. You key that up, you key up 400 repeaters all around the world simultaneously. It's not advisable to go have a chin wag on that because it annoys people. So yeah, that's the good thing about this motor turbo architecture is that this is what it's designed to do. It's designed to use the internet to build large networks. So the local layout, the Australian layout. Okay, so that's essentially, this is how it works. You have the bridge, and then one of these base stations is set to master. That then keys up every so often and tells all the other peers that are running off it that you are here. The system is here. When you turn your radio on, the first thing it does is it basically communicates, it transmits, communicates with the repeater, and the repeater knows it's here, and they synchronise themselves. They stay synchronised with the base station. What you can do is, because these things will send out a pulse every now and then, you can actually, I'm looking at putting another one of these in Sydney, but the idea is you can actually set your radio up so that it automatically votes for the song or signal, so that it knows where to go. It'll do it automatically. It works off the RSSI features inside the receive signal features in this radio.
Does that mean you can walk around and say, find me a repeater? Like, you know, if you go, you get to New York.
Yes.
And you, sorry, was that the answer? Yes.
Yeah.
Wow. Like a cell phone.
So get off the plane, turn your radio on.
Wow.
You'll just go, yeah, okay, here I am. Now, that's what it can do. It can't do it at the moment. The issue is you've got to program that into the radio. Unlike D-Star, these are not field programmable radios. So you have to get your computer, and if you know you're going to New York, put the frequencies in there. Eventually...
Does the GPS locate, or does it rotate and try?
No, it doesn't use the GPS to do that. It doesn't use the GPS to do that.
So just...
The GPS is used in other ways of building these networks. It's used slightly differently. The problem with connecting with GPS so you can bring up maps of yourself where you're wandering around on the computer means you need a $50,000 device that connects the network to the internet. No one's paying for that. Maybe if enough people get together and chip in some money, we might be able to do that. But there's some major changes coming about with the way the site controls. This is actually the trunking systems with how they work. So there might be a bit of surplus gear coming out shortly that can make its way to amateurs. So you can do all that sort of thing. That also means you can, through that same box, you also use your smartphone. You can connect to the radio network with your smartphone. But anyway, as I said, the thing is though, it's still a very, very new network. It's still evolving. See, someone eventually will write a code plug for a particular radio that has global frequencies in it, so you don't have to worry about it. You just have to go to the right zone, right talk group, and it should hopefully work it out. But early days yet. Does that come up yet? It has. Okay. As I was saying, what these things use is a product or a system called IP Site Connect. Motorola has one. Other manufacturers like Hytera, they have their own formats as well. The DMR Mark network, or these DMR networks, there is the main one which is DMR Mark. You have to use these, or the more fancy version which is a more continuous duty repeat. These are just two mobiles and a rack box. These need to talk to the same things. Eventually, yes, the bridges that I'll get to in a minute, they will be able to talk to Hytera or ICOM or any other type of base station eventually, which will expand the usability. There'll be a lot more systems connected to this network. But at the moment, though, the guys who are running this, they have real jobs. They can't do everything. It's just another thing that they would have to try and look after, which just makes it a little bit harder. So at the moment, they've just said, look, we'll just stick with the Motorola stuff until things settle down, I guess you could say. So anyway, as I said, the peers register with the master. Okay, the master sends out the pulses. When you're talking, the actual base station, because it's pulse digital, it actually communicates back with the radio. So if you drop out of range or you're clashing with someone, it'll actually come back and you just get a beep. So the radios, you can't just keep your finger on the button. The radio will actually stop transmitting because it's communicating all the time with the base station. For example, if you go out of range, it tells the base station it's RSSI and that's not acceptable anymore. It'll say, look, I've got a too weak a signal. So if there's no danger, especially in an emergency situation where you think you're talking, then all of a sudden you realise you haven't. This lets you know. Whereas other technology. You just can keep on talking, but nobody's hearing you. Sorry? That's HF, yeah. Anyway, if I lose IP connectivity with this, if the internet goes down, this will just go revert to local mode. So it'll just keep on functioning. This is a local repeater. So anyway, as I mentioned, there's two types of bridges. There's a C bridge and a smart PTT. Anyway, I've given some little bits of paper for everyone here just to give you an idea of some of the links you can check out in your own time. But it explains it. I'm still learning a lot about it myself. I'm not nowhere near an expert on it, but because I do things for work quite a little bit differently to how this is done. So anyway, that's the bridge. That's what it is. Just a computer. So the problem with these is that you're limited to 15 bases hanging off a master. It starts becoming timing and quality, signal quality, or audio quality issues if you try and have too much stuff on one master. As I said, that improves voice. As I said, it does all these features, as you can see there. So that's what it does. That's the way you can get build these really large networks. There's no way you could do 400 base stations around the world off one master. Just would get bad. And the internet has all these other varieties like delay and whatnot.
So what's where it says IPSC? What's the SC?
Site controller.
Site controller.
IP site controller. The Orion network, which is you've probably heard about, which is a trunk network, it has site controllers at every single site, $50,000 a piece. Right, so they're not amateur priced, but they can handle large amounts of users and large amounts of calls, and they're all IP linked together. This is a cheaper way of doing it.
So what's this doing? Just buffering, or what's
it does things like buffering and handling calls as well. So when you want to go on that German language call, you go onto the talk group, the German language talk group, you hit the PTT button just to let the system know that you're there, and then that will go right to the other C bridge, the other C bridges in the network, and say, right, there's a guy down here who wants to talk on that particular talk group. So the system goes, yep, sure, all right, no problems. Anyone talks in that in Europe, it'll come down to Australia, and he'll hear it on his radio. There's no point having every single thing keying up all at once. It just would be chaotic. So there's a little bit of management in there. So it actually it determines where traffic and where people want to go.
And what sort of delays and latency does it add in from buffering?
Well, when you key up these radios, can you hear that? Yeah. That's it. That's the delay. That's how long it takes to key up. So that synchronises the base with the radio. It has to get the sync, so it knows what slots. It syncs itself up. Then it'll send out. It makes that call through the network. That's how it goes. Of course, there is the delay of going to over there and then back again. That's just how it is. But that doesn't really affect the end users. They don't see. They don't notice. They're not in the same room. Eventually, these repeaters will have GPS. The next stage that's coming out is that they'll use a GPS. That will reduce dramatically that synchronised time. So the radios will use their own GPS, internal GPS, plus the repeater has a GPS. At the moment they don't, and that means that the will be even shorter. So users can just practically key up straight away, and the system's ready to go. Provides arbitration to users. If you're on a large group, because there's nets on this thing as well, if you're on a large group and somebody keys up, it'll basically send the signal straight away to not let whoever was first, whoever gets to the bridge first, gets the channel. And it arbitrates that way. Okay, Smart PTT. Smart PTT does pretty much the same. The European part of the system uses that. That's just an app. It's an application running on a computer. The good thing about this is the Motor Turbo system. I don't know about the other manufacturers, but Motorola have essentially said they're like Apple. They've said we'll develop the hardware, the basis of how all this works, and we'll hand everything off to software developers to go and develop all the applications to run on it. So they're very, very good. But radio companies are terrible at developing software, as you probably no doubt aware with software that programs amateur radios. It's horrible usually. So Motorola's realised that, so they just go, right, hands off, we'll give that to other people to do. So a lot of the things like dispatch consoles, tracking, mapping, everything else is all done by third-party software developers, and all you generally need is an internet connection and software and a computer, and away you go. Okay, there it is. There to RCG. So we're up here. Right up there something. So that site has a fair bit. That was taken from the roof of centre point. The only thing that's really tall than it. So that's the equipment there. Not much to see inside, but it handles. It's a DMR system, P25, D-Star, and FM. FM's linked with Horsey Park, as most of you guys know.
Is FM running on a P25 radio? Or is it a separate unit?
They're all separate. That's 4 separate repeaters. Can't mix the strings, you know.
We do.
Now, when you're linking, you can't have. It's impossible to link to have mixed mode when you're linking. The P25 goes back to a vote. Well, it doesn't at the moment, but it will go back to a voting shelf, which basically. Once the P25 like this is set up, you'll be able to program your P25 radio so that whatever site comes in best, that's the one you go out with. And that is then linked to a global P25 network. Okay, now, just to show you a few of them. Okay, so that shows, if I get that one. Okay.
Oh,
There's me. Now, we were talking about these ID codes. This is what everybody uses around the world. They're using this for DMR as well as P25. So my DMR ID, which is 505, oh, actually that's the repeater, that's 505-201, that's the repeater here. Another one, there's Matt.
oh yeah.
So, okay, there's the actual, this is the actual monitoring system. That's showing all the repeaters that are currently active in Australia and around the world. So there's not just those ones, there's these and these and these and them. So it shows the time slots in use, and all that sort of thing. Now if I go, if I right click on, okay, so that's showing me. So I'm a little bit marginal because I'm in this metal box, but there's my ID, there's Matt. BK2 DAG, BK2 CF. Yeah. Oh, you're here.
Cross band!
Hey? Oh, talk back, come on. Anyway, he'll come up there as well. So, and it shows the signal, the RSS and signal strength of where they're called. There, so there. But that's as I said, that's why we're all using these 505. So if I go to yeah, that's right. You can't read it, but that's P25. That's the P25 system. That's why it's important to use those numbers from DMR, because there's a central server and it just automatically translates your ID with your call sign. And
Because you've registered or something.
yes, because you've registered. So it knows. If you use the ACMA or you use the other way, your customer ID goes, huh, who's that? Doesn't know. And as this P25 system gets more sophisticated, there's going to be more talk groups and allocations. At the moment, when you key it up, it just keys everything up. Or there's 3 repeaters in Hawaii. There's one in Texas. There's one in New York. There's one in Germany. Where else is there? Anyway, there's quite a few of them, and that network is growing as well. Eventually, we can't just have one big talk group for everything. We'll make it into actual various talk groups, so you can have a chit chat while you're driving around Sydney. You don't have to annoy the rest of the world. Anyway, I think that was what I was going to say. Now, the network that I built. So, which is called Orion. 1, 2, 1, 2, 1, 2. Right, so it's coming through. But if that's on the Dural radio network, but that's saying the interfacing with the internet, I've got an app on the phone. 1, 2, 3, 1, 2, 3, 1, 2, 3. So, you know, a lot of users who may be out of coverage or out of the range of this system, just give them an app for their smartphone until the network catches up with them. A lot of bangers won't like that. But that shows you what we can do with this, we can do with amateur radio as well. So, you know, if you go someplace where you want to just listen into your local repeater or local talk group, you just get an app on your phone and you can still do that. Or if you're in an aircraft. If you're flying an aircraft, the plane has Wi-Fi. You chit chat while you're on the plane. They won't let you do that with this. So yeah, that's the. I guess that's it really. But as I said, Mac's got up there. He's got a Hytera, which works fine.
Full of radios to show off.
Oh, we've got a box full of radios to show off. You bring them on down, Matt. Look at that. Wow, what a treasure trove. So there you go, there's a Hytera. That's an early Motorola. These are starting to come up on the second-hand market, these 3600 series. And shortly there's going to be some major changes on the trunk-type radio networks where these don't have enough memory. So, guess what? There's going to be bucket loads of them coming out.
So what sort of their current prices?
I don't know, I never paid for that. Have a look, but there is that little bit of paper there. There's Connect Systems International. They have a $250 port that'll go on this network. So that's brand new.
And they're working on a multi-mode one which will do
DMR,
analog, and D-Star at the same time.
Yeah, P25 will be the problem because of the licensing issue, but the other bands, yeah. Once you've got those, the ambi chips, yeah, they're all pretty much compatible. Now, if you wanted me to, I've possibly got time. I could maybe have a bit of a break. I've got a test set that can be plugged into that, and I can actually show you what it looks like what it actually looks like in the RF world.
Quick question. Some of the later Yaesu radios have got digital mode. Is that this or is that something
That's
new
Fusion.
yet again?
Yeah.
So another radio I've got to buy.
It's completely. I don't know why they did it.
Okay.
Especially when they were owned by Motorola, and Vertex Standard, which used to be part of Yaesu, they simply got these radios and rebadged them, and those base stations and rebadged them. Even though the two, if I got one of these Vertex Standard repeaters, it won't talk on the network, and if you try and change it, you brick it. So why the Japanese? They're strange. I don't really understand it. Kenwood's gone down the next edge path, and it makes you sound like a little girl. And that's the audio's horrible on it. And ICOM's done IDAS, and I played with that for a little while, and it wasn't very good. I don't know if it's been fixed yet. And then everyone else has gone down the DMR path. But those guys are now on the DMR Association. Whether they'll have something soon, I don't know. The Chinese will just kill them. They've already got the march on them now. So I don't know what those guys are going to do. But ICOM's a classic example. They have the amateur radio division, the commercial division, and they don't even share the same lunchroom. They keep everything completely separate. They don't talk.
But they've chose another digital standard for their commercial, which is even
IDAS.
which never works.
IDAS. Another one.
Yeah, for a small commercial.
Oh, well, it keeps the engineers employed, I suppose, doesn't it? I don't know how long they can pick that up for. Right. Anyway, I hope I answered questions or whatever. Yeah, that's DMR. So it's making big inroads, and there's a repeater up there works quite well, and more than welcome to use it. Get yourself a DMR radio. But I do stress that you go to the DMR Mark website first and read the instructions, so you don't really annoy people. there's certain things you've got to do. Another thing too is setting up your audio levels is very critical, because you can, with AGC and what these have caused all sorts of problems. But there's actually a talk route you can program into your radio, and it links in to a screen on a computer, a website, and you can actually key up and adjust your levels. You set your levels up to get it just right. So that's the real fun thing about there's all these applications that are out there, and nothing's stopping people from developing their own.
Eventually, you're going to have your mobile phone, and you're going to have an app for each protocol across the internet. What do you mean, Ira?
Well, true. Well, I mean, as I said, you've got this. This isn't as good as you see. It's got delay and it's a bit clunky. It's not as good as actually having a radio.
Yeah.
Still not as good. But the app is just designed for management, because quite often we roll out, put a fleet of buses, a whole lot of radios and buses they can track and do everything else, and they management says, oh, I've got to have a radio. I want to listen to what's going on. So they guess which radio they get. That, right? So they get that one, and quite often we've got to do an upgrade, and they never get the upgrades because it's switched off flat in their drawer. So it's a waste of a quite expensive radio just to be sitting in a drawer and never getting used, because you've got to have the radio on to get updates and change talk routes. They get it out, dust it off, and then why can't I hear anybody? What's going on? Oh, this is a crap thing. It's because their radio has missed the send out. When you want to send out a file to a group of radios, you basically it keys up one slot.
Whoa.
It keys up one slot that sends out that you can say, I want to send this file for an hour or 2 hours. So you do it, say, after peak hour in the morning, you do it, say, at 11 o'clock, and you let it run through to about 1 o'clock. And then hopefully you get all the radios. You might miss one or two. Someone rings up, and they soon ring up, and you say, right, turn your radio on. And then you bang up the file for, say, 20 minutes, and then they'll get it. And basically the user doesn't see that happening. Once it's got its file, it does a check to make sure it's got all the information, then it restarts and runs off the new code plate.
Like a TV program.
Is that how the police kill radios that go missing?
Stunning.
Probably. These do have stun as well. They've also got screen blank, so you can actually turn the screen off, so the thief thinks the radio's not on. For example, a car gets stolen, the radio's on, you can actually program it so that if they haven't turned the radio off, you can actually get it to just kill the screen.
We can also listen to them.
And you can also key it up, have it so it keys up with no PTT lights on or anything. It just sits like a dark radio, and it will actually send the microphone audio. So if someone holds up a bus, for example, you can covertly listen to what's going on, what they're saying.
You know, worry and boss is listening.
Boss mode.
Boss mode, yes, that's the one. Yeah, but it seems like every couple of months something new comes out with all these new. Hey, try this feature. There's a conference every year in Las Vegas. I never get it, but there's a conference in Las Vegas that is just this, where they have all these new products, vendors, and all these people developing all these software apps, and they just give you USB sticks. Try this, give this a try, and they just come out with all these things. So it's really kind of revolutionised how two-way radio's always been a bit stodgy. Not at all. It's really. I have trouble keeping up with all this stuff. Anyway, but the good thing is that it means a lot of potential parameters once we seriously get into it. Any questions? I don't know. I've not tried it. There is a way you can make the mobiles that are out of band go down. I haven't tried it.
And all the high tiers you can get stuck into.
Yeah, the high tiers, you can trick them. These radios here though, the 4000 series do 400 to 520. Damn, they're great. You don't have to worry about tricking them, they'll just do it. The mobiles won't, the new mobiles like these ones, they won't do it, but those ones will. At the moment. The next version they might bring out might have the same chipset, it'll just be 400 to 520, no gap. Yeah, but these ones, these are banded, so 400 to 470 and 450 to 520. Most of the Orion, all the Orion ones are 450 to 520, because that's a source of future amateur radio gear when they get upgraded. Same with the base stations. The base stations are banded like that as well.
And so, one more question, that repeater that's up now, you've got to be on the MARC network obviously to use it.
You can use it if you want, but it's not a good idea to just put any old ID in the radio, because it may clash with somebody else's somewhere else in the world.
Yeah.
It'd just go to chaos if there wasn't a central database of numbers to give them.
Yeah. And then you can still just use it locally for Sydney. Yeah.
But yeah, you don't have to, if you adamantly refuse to go on there, that's fine, you can still use it, but
Yeah.
you won't win any friends.
Yeah, no, I'm not worried about that.